All right, so we're looking at factors affecting solubility in this lesson. There's three of them. We've got temperature, pressure, and miscibility. And these three factors, as we change them for the solvent, so in almost all cases water, then that's going to have an effect on the solubility of a particular solute that we're trying to dissolve in the water. So let's take a look at temperature really quick. First of all, when I have the temperature of the water really high, or as I increase the temperature of the water, that's going to have an effect on a solid solute. So a solute that has a state of matter of solid. And as you can see that I've written down here, it just says that as the temperature of water increases, the solubility of the solute is also going to increase. So an example that you're all familiar with is hot chocolate mix. If you warm up, say, water really hot, then you're going to be able to dissolve more hot chocolate mix crystals in that water and make your hot chocolate a lot more chocolatey. If you had it as really cold water, you wouldn't be able to dissolve as very many crystals, and your hot chocolate wouldn't be hot, and it also wouldn't be very chocolatey. And so that's for a solid solute. As temperature increases for the solvent, the solubility for the solute is also going to increase. But we can also dissolve gases in water as well. And when I have a gas solute, if the temperature of the water is really high, then the solubility of that solute is going to be actually really low. And so an example of this is if you've ever drank a can of pop really quickly. Soda pop has carbon dioxide dissolved in the water. That's what gives the pop its fizz. And so when you drink that, that pop that's most likely pretty cold and you've just gotten out of your fridge, when it hits your stomach acid in your stomach is, your insides are all 37 degrees Celsius regular temperature, and that's a lot more warm than what the temperature of your fridge would be, and also the pop that you just drank. And so as that solution starts to warm up, then the carbon dioxide gas molecules that are dissolved in the water, because the temperature of that is increasing, the solubility of the carbon dioxide is going to go down. And so over time, very shortly, after you drink a whole bunch of pop, you get this buildup of gas inside your stomach, and then you end up burping all of that gas out. And so when you burp after drinking pop, you're just burping out carbon dioxide that was dissolved in the pop originally. And so as the temperature of the water increases, the solubility of the solute will decrease. And that's for a gas solute. Now, that's just for temperature. For liquids, liquids do and are affected, liquid solutes are affected by the temperature change of solvents when you try to dissolve them, but the predictability of it is really not that great. And so I leave it off the list here just because it's not something that's really cut and dry. And so we'll just worry about solids and gases for this factor that affects solubility. Pressure is another factor that affects the solubility of certain solutes. And because gases are the only state of matter that are affected by pressures, naturally it would make sense that gas solutes are the only thing that are affected by pressure changes. And so, as you can see here, is as the pressure is ramped up, the solubility of the solute also increases. And this is because if you remember from Boyle's law, a gas, when it's under high pressure, the volume of that gas is going to decrease because pressure and volume are inversely proportional. And so if the volume of the gas is a lot smaller, then those gas molecules are going to be able to fit into smaller spaces in between the liquid water molecules, and therefore be able to dissolve more, so the solubility increases. So that's pressure. Miscibility is defined, this is a little bit of a weird one, it's defined as the ability to be mixed. So we have substances like certain liquid solutes that can be mixed with water and can't be mixed with water. And this really has to do with, if you remember from the bonding unit, substances being polar or nonpolar. Because water is a polar substance, other polar substances will dissolve and therefore mix very easily with water. And so a liquid that is a polar solute is going to be what we say very miscible with water. it's going to be able to be mixed with water quite well. And therefore its solubility would be quite high. In fact, basically infinite. You could mix an undetermined amount of liquid in that water and it would mix and dissolve. Conversely, if I have a nonpolar substance that's not like dissolves like, that's different, because a nonpolar substance doesn't dissolve in a polar substance like water, then we would say that liquid solute that's nonpolar would be immiscible. So it wouldn't be able to be mixed with water. So examples of that would be like oil. If you try to mix oil with water, it'll kind of just separate really quickly. Or gasoline with water, that separates as well. And so those are some examples of that. If a substance does not have a very high miscibility with water, then the solubility of that substance is not going to be very high. And that's it. Those are the three types of, those are the three factors that affect solubility.